Assalamu alaikum guys. So in today's lecture we are going to do the block diagram and we are also going to discuss some environmental issues of power generation, renewable and non-renewable resources and Einstein's mass energy relationship. So these are some topics of our today's lecture and we will also discuss efficiency and nuclear fission reaction. But that will be in the next class, okay? Not in this class. So so let's start. So we will do in today's class the block diagram. So what is the block diagram? We will it is a diagram of creation. It is just a diagram, okay? So today we are going to do the block diagram of electricity generations, okay? So first let me make the equation that what happens like first chemical energy. So in a so let me show you the diagram, okay? This is the block diagram of creating energy. And this what happens is that coal supply is provided in the boiler, and in this boiler the coal is burned, from which the chemical energy is stored, is released and transferred to heat energy. And due to that heat energy, the boiler gets heat, and due to that the water is converted into steam, and that steam goes into the turbine because when it is converted in steam, the steam has the movement has the property of kinetic energy. Then due to that kinetic energy, the it makes the turbine move. Okay, so it makes the turbine move over here due to the steam, and after that, when the turbine is moved, the generator starts and it starts making the electricity and provide it to the transmission lines. Okay, and when that steam is used, it's converted again into water because of the condenser. After the turbine, the steam goes through a condenser which makes it water again, and that water is again used, and some water is then purified here and sent to the storage tanks. Okay, so this is how electricity is made in a in a in a generator. Okay, in a generator, basically you may say in a power plant. Yes, I wasn't having the basic word. Sorry. Yes, what did we learn? Okay, so what happens next is that basically in this diagram, what happens is that chemical energy is transferred to uh, to kinetic energy, and that kinetic energy makes the turbine move, and due to that movement of turbine, electricity is transferred. So let me write the equation that chemical energy is transferred to the boiler. That boiler makes the steam move to the turbine, and that turbine, what does it do? It moves that energy created to a transformer, okay, to an up transformer, okay. So then, due to this transformer, electrical electrical energy is created. So this is the basic of a block diagram. So we are done with the block diagram. So now let's start environmental issues of power generation. Okay, so let's start environmental issues of power generation. So the first environmental issue that is that the burning of fuel like coal causes air pollution and air pollution like CO2. Okay, so this is the first environmental issue. Then the second issue is the construction of huge dam reduces the forest area. Okay, so when dam is created, the forest area is cut down. So the third point is in the nuclear power generation produces radioactive waste and byproducts, which remains harmful for a long time. Okay, so these 3 points tells us that there are environmental issues of power generation that in hydroelectric power generation the forest area is reduced. Okay, in nuclear power generation, what its byproducts or the radioactive waste remains harmful for a long time, and the burning of fuel like coal causes air pollution. So we are done with the environmental issues of power generations. These are some environmental issues. Now let's let's do that. Let's write some examples of renewable and non-renewable resources. So what is renewable, by the way? Renewable means that it can be used again or can be recycled. Okay, so in this, wind comes, and tidal energy means the waves also comes, and geothermal also comes because the energy is continuously producing. And solar energy also comes. Okay, and in non-renewable renewable which sources come? In this, coal comes because it can't be used again. Okay, coal comes, and with it oil comes. Gas is also a non-renewable substance, and the radioactive nuclear is also a non-radioactive nuclear is also a non-renewable resource. Okay, so now we're done with these. Now let's start Einstein's mass energy relationship. Okay, so so what is Einstein's mass energy relationship? So, in this relationship, it states that matter can be converted into an energy, and energy can be converted into matter according to the following equation: E is equal to mc square. So this is a famous equation which is E is equal to mc square. So in this equation, what does E stands for? E stands for energy. Okay, energy. M stands for mass in kg. Okay, and energy unit is joules. SI unit. Okay, and C stands for speed of light. Okay, speed of light in air. So, and its value is basically 3 times 10 to the power of 8 miles per second. Okay, meter per second. So, let's do an example, a question from past paper. So, let me write the question. If 500 gram is completely transformed into the into the energy, then calculate the energy released. Then calculate the energy released. Okay, so let's start it. So energy release means we have to find the E. So E is equal to mc square, right? So we have been given M, which is 500 grams. First, we have to convert 500 grams into kg. So for doing it, we have to divide it by 1000, and the answer is 0.5. And C value is uh, 3 times 10 to the power of 8, and here's the square, so hence we put square. So let me check it in the calculator. So its answer is times 4.5 times 10 to the power of 16 joules. So if we want to convert it in kilojoule, what we have to do? We have to divide it by 1000 or divide it by 10 to the power of 3. So 10 to the power of 3, when we bring this 10 to the power of 3 up, so it becomes minus 3, this 3 becomes minus 3, hence it will, so the final answer for kilojoules, if you want to find it, will be 4.5 times 10 to the power of 13 kilojoules. So this is the first question which is just solved. Okay, so now uh let's do another question. So in this question, the energy is given. Okay, energy is 2.5 times 10 to the power of 17, and we have to find the mass. Okay, we have to find mass, and so let's start. Okay, we have been given energy, so it means E is let's me first write the formula mc square. So E is 2.5 times 10 to the power of 17, which is equal to m is unknown, and c is 3 times 10 to the power of 8 square. So let's isolate m. For doing that, what do we have to do? We have to bring this to that place. So 2.5 times 10 to the power of 17 upon 3 times 10 or 8 or 8 square, which is equal to m. So let's calculate it in the calculator. Wait, let me do it. So the answer is 2.77 kg. Okay, this is the answer. 2.77 kg is the answer for the second question. Let's do another question. So in this, uh, mass is given. Okay, 2500 grams. Okay, and from it, some mass is uh, and then the mass is reduced. So means the final mass is 235. Let's take 2350 grams. And first, what we have to calculate the energy of the mass which is lost. So the lost mass will be 2 2500 minus 2350. So the answer will be 2150 grams of mass is lost. 150 grams of mass is lost. And when we calculate it into kg, it's become 1.5 kg mass is lost. So we have find mass, and we have to find energy in this question. So E is equal to mc square. E is unknown, m is 0.15, and c is 3 times 10 to the power of 8, the whole square. And by this, what do we get? Energy, right? So what's the energy? The energy is 1.35 times 10 to the power of 16 joules. So, and there's another part of this question, and in this question, we have to find power also. Okay, so power is equal to energy upon time. P is equal to energy upon time. Yes, E upon P is equal to P. So for P, energy is given 1.35 times 10 to power 16, and the time which is given is 2 minutes. Okay, so first we have to convert this into 120 seconds because the SI unit is seconds. So then upon T is 120. So by this, we find the P, which will be 1.125 times 10 for to the power 14 watt, right? So how do we convert it into kilowatt? By dividing by 1000 or dividing by 10 to the power of 3. When we move that 3 up, it will subtract from 14. So the final answer will be 1.125 times 10 to the power of 11 kilowatt. If you want its answer in watts. Okay, so we have covered this is equal to MC square. I hope you guys have understood it until now, that how did I solve these questions, these past paper questions, and you have understood that in this, what does it says? It says that matter can be converted into energy, and energy can be converted into matter according to the final equation E is equal to mc square. That's the basic explanation for it. Okay, so now let's do efficiency. Okay, so basically, what is efficiency? So efficiency is the ratio between output and input. Okay, so it is the ratio between output and input. So this is the definition of efficiency. The ratio between output and input is called efficiency. And how do you take out efficiency? You take it out by energy output upon energy input times 100. Okay, so this is how we take out its efficiency. Okay, like for example, here is a fan in which we give 100 joules of electricity, and it takes out 30 joules of electricity. It use 30 joules of electricity in making wind, okay, in producing wind. So the 70 joule energy is either transferred in sound energy or in heat energy, okay. So how we write its efficiency? So the efficiency will be, as it is energy output, which is 30 upon energy input, which is 100 times 100, right? So the percentage, so the fan will be 30% efficient, right? So that's it for efficiency. Now let's do nuclear fission reaction. So in nuclear fission reaction, what happens that a neutron hits a parent nucleus, and this reaction, what happens that this nucleus breaks into two, okay, and by this breaking, energy is produced, and these two nucleus are known as daughter nuclei. So when this one neutron hits this parent nucleus, three other neutrons are created, and with it, two of the daughter nuclei are also created. And this reaction, energy is a lot of energy is created, and we use this reaction in power generation. Okay, so so what happens is that in this reaction, that when, for example, this parent nuclei has a weight of 2.5, right? 2.5. Okay. So when it breaks up, this daughter nuclei will get, let's suppose, 1.2, and this will get 1.19, right? So when we add these two to this 2.5, the answer is not the same because some of the mass is converted into energy. Okay. So let's suppose, so how much is converted energy? First, we have to find this. How much mass? So it will be 2.39. So it will be 0.11 gram of mass is converted into energy. Okay. So 2.11 gram of, sorry, 0.11 gram of mass is converted into energy. So for so to find out energy, what do you have to do? That how much is the energy of it? So we have to first convert it into kg, 0.11 times 10 to the power of 3, negative 3. So for finding its energy, that how much 0.11 energy, 0.11 gram has made the energy, we put it into E is equal to mc square formula. So m is 0.11 times 10 to the power of minus 3, and c is 3 times 10 to the power of 8 square. So when we solve it, let me put it in the calculator. So the answer will be, yes, so the answer will be 9.9 times 10 to the power of 12 joules. So this huge amount of energy is created by just 0.11 gram of mass of nucleus. Okay, so from 0.11 gram, 9.1 times 10 to the power of 12 joules energy is created. So that's too huge, mashallah. Hence, hence, hence we don't use these kinds of reactions, okay? Because they are too reactive. And in nuclear, so we are done with this nuclear fission reaction. Now let's do nuclear fusion reaction. Okay, nuclear fusion reaction. Okay, so in this reaction, what happens is that two small daughter nuclei, okay, wait, let me, two small daughter nuclei joins up to form a big parent nuclei. Okay, in this reaction, this happens. So let's suppose this has 0.1 gram mass and this has 1.0.12 gram. but the parent nuclei will form 1.9 gram. So in this also some of the mass is converted into energy, okay? And from this, what happens that one neutron is also formed. When they both joins, one neutron is formed and the parent nuclei is formed. So in this, how much mass is transferred into how much mass is transferred into the energy? Let's find out. So 0.19 gram is the parent and the total is 0.22. That's subtracted, so it becomes 0.03 0.03 grams of 0.03 gram of mass is transferred into of milligram masses, because this is zero point 0.2 milligram and this is also milligram and this is also milligram. So 0.03 milligram mass has been transferred into the energy. So let's check that how much energy is produced by 0.03 milligram. So first we have to convert it into kg. So for converting it, let's convert it, and this is into kg. 0.03 times 10 to the power of minus 6 is equal to kg. So let's find out the energy. So E is equal to mc square. So m is 0.03 times 10 minus 6 multiplied by 3 times 10 to the power of 8 square. So the answer will be 2.7 times 10 to the power of 9 joules. Okay, so this huge energy is created from just the small amount tra- of matter. Okay, so hence this reaction is also used in the atomic bombs. Okay, this is how the atomic bombs are used. Okay, and so this is the last topic of our this chapter, and with this we have completed the chapter, uh, and work, power, and energy at last. Energy was one of the big chapter. Okay, this whole chapter we have covered. Okay, mashallah. So alhamdulillah, we have covered this chapter. Inshallah, in the next video I will soon be uploading this video, and in the next video we will be doing a new chapter, inshallah. Hope so. Do pray for me. Okay, guys. Allah Hafiz.